What's my phone for today? Remember my phone for today. My next object is system with return. What if we have something and output is connected to the input? That's my question for today. Closed loop systems. It was the idea of closed loop system. But before I'll speak on closed loop system, I want small supplement. It's an idea of linear stage or simple. Okay. I would like to introduce idea of linear stage, linear system. Partly because I have a good demo. You saw something like this. Or maybe like this. What's this? It's a trace of gone civilization. It's a triode. Bit forgotten technology. Idea. You have a vacuum tube. You have a heated cathode. It's hot, it can emit electron. You have anode, method, and source. In my case, it was 250 volts. If only like this, what it will be? Diode. Make small diode for 100,000 volts. This one is for 100,000 volts. It's from old Röntgen unit. 1, 1, 0 and 3 zeros of volts. It's still an operation condition. Diode. Now we have small semiconductor diodes, but not for 100,000 volts. What's the idea? Why I'm drawing? I have a blank space here for the grill. Anode, cathode, grill. Camera. second, I made a stupid thing. I didn't switch views. Here, camera control close, anode, cathode, and here my finger points on grill. Let's say I have current here, cathode is hot, here at a plate, another name for anode is a plate. Plate is under high tension. Someone named electron can leave cathode. Electrons have negative charge, yeah? Assuming. What if grill will have negative charge too? It will push electrons back, yeah? And if positive, it will accelerate them. If electrons are accelerated, let's say I have source A God, okay, it's only A, and I put a voltmeter here to measure A God. It's a grill voltage. What effect will have positive grill voltage on the current? Electrons are accelerated, this means what current can flow easy, yeah? So, current will increase. And negative charge will decrease current. Maybe. Or, cathode heated, grill voltage applied. So, one moment, I will put camera in the way everything is visible. Here. Upper meter shows grill voltage and lower grill current, anode current. Sorry, anode current. Look what will happen. Minus 100, nothing happens. Minus 80, nothing happened. Minus 37, nothing happened. Minus 5, minus 4. Oh, small current arrived. Minus 2, 8 microamps. 3 volts, 36 microamps. 2.8 volts, 70 microamps. 4.8, 96. 6 volt, 180. 10 volt, 153. 13 volts, 16 volt, 108. See, I can control current of anode with the voltage of the grill. Negative voltage, no current. 0.6, 53 microamps. 4.8, 96. 7.6, 128. 11, 106. 126 volts, 183. If you draw a chart, and know the current as a function of grill voltage, it will look like this. In this part, we can delta A dot corresponding delta anode as stiffness is a delta anode against delta A gap. It's a parameter of my electronics value. I would like to assemble a simple schematics. My triode, because it had 3 electrodes, here will be anode resistance of 250 volts, capacitor, this will be good. Yeah, I will a graph capacitor, and this will be a 6 of time. I need these capacitors to separate DC component. Okay, this one will be, this one goes here. It's anode, and how do I get input signal? Input signal, input signal, input signal. I need connection here. Give me some wires. You go here, ground, on ground. This is my ground. This is for scope. This is scope. And I need wire to. I need wire for my generator. Wire. More wires for the gut of wires. Oh. Kilohertz. Okay. Oh, signal of 10 kilohertz comes from the primary side. I need camera as well. Yeah, like this. Yeah, the yellow line is an input signal. And blue line is an output signal. At this moment, green voltage is minus 25 volts. Again, chart anode current as a function of grill voltage. I'll try to change grill voltage. In opposite direction. Whoa. Whoa. I need measure, isn't it? Measure, 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 channel 2, measure, 1, 1, 1, 1, 1, okay, RMS, oh, no, please. Speed, small, half a volt. Oh, do you see what I'm seeing? Input is assigned with the effective value of 500 millivolts, half a volt. Output is assigned, but amplitude 1.3. This way better. Not 10,000, but 1,000. And I definitely need to change scale. Oh. What would you say about this? But this picture is better. I have half a volt at the input and 4 volts at the output. 8 times higher. Why? What's going on? First current. At this moment, I have selected a glass something somewhere like here. You remember I have added capacitor. Time Sx as a function of time is something like this. Yeah? Yellow line. What will happen with another current? If Sx goes up, another current goes up. Another current will repeat grill signal with a factor of what? What will be ratio between this is input and this is another current? What will be ratio? Stiffness of this line. Yeah? You understand why? Now my circuit. Here is output. Not important, here is input. If another current increases, what happens with voltage on this point? Resistance of the valve. If current increases, this means what resistance decreases. Yeah? If resistance decreases, what will happen with this voltage? Goes down. And I can draw it in a mirror. I can. This one is SY. See? Output is input but amplified. Look what happens if I change a gap. Smaller, 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 nice and fine, and again, see this kind of corrupted. Why it's corrupted? I have working point minus 3 volts. I'm not in the linear part of the characteristic. See, it's wave of pulse. I need nothing corrupted, good linearity, and 13 volts. I shifted a point, working point here. We see a limitation, but it's still sine. That's why people are paying high prices for the valve acoustic. Because of this proper soft limiting and the good linearity. You see, it's linear. I have a demo of linear amplifier here. Input half of volt, output 4 volt. These demo valves are not very good in amplification. This one, once were used, it's 1.5 kilowatt. This thing is for 1.5 kilowatts of natural power. It was used for city broadcasting. Actual device had 6 of them. To broadcast over the city, 6 such valves. Not all are such gigantic. Here is a tiny high frequency triode. Same thing, 3 electrodes, but this one is for high frequencies. Quite a nice device. But why I'm telling? Why I'm spending time on this? Idea of linear circuit, this linear stage, where output is input just multiplied by amplification factors called scale. You see, output is input. Here I have K minus A approximately. Yeah? Okay, I will use this idea. This one is dead. You can compare here with another one, but it's not a triode, but tetrode. It has 4 electrodes, 2 grills, and made in May 45 and still operation. A week ago, I saw prospect of home audio system, 2 channels, 10 watts with these valves. For mono box for 1 block for each channel, and 1 and 2 JM 100. Okay. I need to clear some space, and now we are able to speak on systems with return. I need to analyze something like this, where I have, let's say, the direct channel with transfer function K as a function of your omega, and return circuit with transfer function beta. Output, let's say it's E, and here, let's say we have O. What will happen if I put a microphone to a speaker? It will be a system with return, or with the feedback. Another name of it, system with the feedback. System with the feedback. I can take this one. Oh no, it was a good idea. Good resistance. So I'm interested in real transfer function. I'm interested in ratio against E. Transfer function of the whole system. Actually, be careful. This E is in general complex and a function of frequency possible. It's something what can be function of frequency and just simplify. Okay, write something. So I have direct, let's say direct pass and return pass. Output from the return is beta transfer function multiplied by voltage at the end of system. I can write this voltage as a direct transfer multiplied plus UP or direct transfer function multiplied by A plus transfer function output. I'm simple. This output is in general it should be spectral function. I can solve this equation relative to the output. It's easy. So, solution of this equation will be divided 1 minus omega beta n. This means what real effective transfer function is what? Direct stage transfer function divided by 1 minus beta. K is transfer function of the system with return. It's better to perform analysis in Laplace space. What about Laplace transform? Who heard about Laplace transform? Only one? Really? 2, 3. What's the idea general of Laplace transform? It's the same Fourier transform, but operates with the complex frequency being omega or s sigma plus your omega. You can write this both forms, there is no difference. Absolutely. It analyzes in the space of complex frequency. Just substitute this frequency. It's imaginary part of the Laplacian frequency. So 0 as a function of Laplace frequency will be direct 1 minus direct beta. Case resulting actually we can modify systems with the frequency response with the feedback. You can have quite low grade amplifier, introduce deep return, negative return, and it will show great results on tests. Okay, it will be great amplifier with a very good test mark. Where the dog is digging. Where's the biggest problem? Can you name an example system with return? For example, someone driving a car need to maintain stable speed. Just drive directly. Where's the feedback? Where's the road? Where am I? Yeah? What's stable driving? Steady. Or unstable? Imagine someone just first time at the wheel. To the ground. Oh no, full brake. To the ground, full brake. What we will see? Not a driving, but chaos. Question. Core question. Yeah, I can create system with feedback. For example, voltage stabilizer. Take a feedback voltage to the amplifier and amplify the difference to get it to 0. Nice? Nice. But what about stability? Key moment of the system is we have a lot such system around us is stability. Ball and the covers. This system is stable. I can push a ball out, and what will happen? It will return. Absolutely unstable thing, yeah? I can draw something like this. Stable, but in limited interval. Now question. I'm creating control system, I don't know, or amplifier or something, where there is direct channel and feedback. Amplifier and microphone in same and speaker in same space. System with feedback. Yes, it's system with the feedback through acoustic. Key moment, stability. Yeah, we can speak in general. What the bigger is absolute value of k multiplied by bet, then less stable will be system. But can we, let's say, analyze, have something measurable? Okay, let's imagine we have an nth order system. What can be described as what can be described as a differential equation? A1 and minus 1 x. Here x something what we can call process variable. We observe something, and x is process variable. 1 plus a n minus 1 x by 10 plus a n x equals to 0. Let's say we can describe our process with such kind of differential equation. Many processes in this world are describable with such kind of equation. Here x, I don't know, it's maybe voltage, current, water level. Yeah, water level in your toilet. It's also system with feedback. And so something maintains water level in the tank of your toilet. System with feedback. And it can be unstable, it can be do. Solution of such system is known. So, solution of such system is sum where I change from 1 to number of ai a power lambda I, where a are constants. We saw it on a resonance contact, where a1 and a2 were both the constants, and lambdas can be found as a0 lambda plus a1 lambda n minus 1 plus a n minus 1 lambda plus a n equals to 0. Solve this equation and you will get roots of the characteristic equation. These roots are for system that can oscillate own frequencies or or oscillation frequency. For non-periodic system you will see only decays. We can assume one thing. If real parts of lambda e starting from 1 to is less than 0, this means what system is, what kind system is dissipative and system is stable. This system can be characterized with decaying amount of energy. So system will go to some at the end to some kind of stable state. If one root has a positive real part, the system will not is unstable. What can I do? So let's say we have a0 and then U from time. Let's say we control voltage. A1 Vn minus 1 U n minus 1 blah 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 equals to, let's say, some E from time. If we perform a Laplacian transform on U of time, what we will get? We will get its image as a function of complex frequency. And my equation will become A0 En, or maybe, okay, not to confuse it, lambda, but here lambdas will be complex frequency as Laplacian. Was R1 lambda n minus 1. Sorry. Plus, what will I get here? R lambda plus An equals to the image of the source voltage. From this, I can write a transfer. So transfer in a space of Laplacian transform being output divided by input, and here I will have 1 divided A0 lambda n plus A1 lambda n minus 1 plus Rn s1 lambda plus An. Roots of characteristic equation corresponds. What happens if I put a root here? All divider will become 0. Yeah? When divider becomes 0, this radial becomes infinity. At this point, I can draw it very schematically. Something like this. It's called polar. It's a point when function goes to infinity. At the polar, in theory, function should go up infinity. Goes up. So, system will be stable we have if all lambdas are on the left side. If all roots is less than 0, system stable. If one root, if one pole sits on the right side, system is unstable. I can show it on example. Possible, I have time. let's see. I have a linear part loaded with capacitance, resistance, and coil. Here will be plus. To ground and grill. There you go. F. The idea, I have a linear amplifier loaded with resonance circuit. This resistance is to show equivalent losses of the contact. Resonant contact, but contact is coupled with mutual inductance to the input. System with feedback. And I can control this feedback via change in mutual inductance. Here I can approximate, write this direct transfer as minus Z of this anode contact. This one, what's this? Let's say AB. Coil, capacitor, resistance. AB. This part, resistance of this anode load. And beta return plus minus M divided by this, as we saw it previously. ZAB omega can be written as F divided 1 plus L dot omega plus one dot omega L con. I can do it. In terms of Laplace transform, I just need to substitute dot omega with the Laplace and frequency p. So, will be blah 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 1 divided by p divided by p squared plus 1 L k should be p plus 1 divided ck. What can be rewritten as 1 divided by c complex frequency p squared plus double alpha p plus omega 0 squared. Here, alpha 1 divided by double LCP. What's an alpha? It's characterized decay. You remember oscillation? Goes down. This goes down, this decay is characterized by alpha and omega 0, 1 divided LKCK is a free oscillation frequency of the cone. I need time to assemble network. I would like to show it live. So transfer function being divided by 1 minus from P beta from P, where P is a complex frequency, will become, I'll simplify, minus S divided by contour capacitance, here frequency square plus double alpha plus beta S divided by CK, formula continuous, multiplied by complex frequency plus omega 0 squared. There is one question. At the moment the frequency is equal to resonance frequency, our transfer at omega 0 will be minus SR. Why minus? Remember, when a guy increases, another current increases, but voltage at the dividing point decreases. You saw it's inverting. Oh, this amplifier inverting. When input goes up, output goes down. I need second 12 to compensate this minus side. That's mean one thing. Meaning what if beta is plus M plus AK? What kind of return we will have? Negative. Feedback signal will work against amplification. So this one is for negative feedback, and minus M will be for positive feedback. This one pushes down, this one pushes up. So for negative feedback, assuming beta plus M against AK, we will have real transfer function as S divided by CK. Here we will have frequency P square plus double alpha plus ms omega 0 square P plus omega 0 square. Root of the divider, roots of the divider, 1, 2, will be minus alpha plus ms omega 0 square divided by plus minus square root of it will be complex, it's a frequency omega 0 squared minus alpha squared plus ms omega 0 squared divided by 2, and it should be taken squared. As you can see, this part is negative. This should tell us what system will be stable in any case. Who trust I need to assemble it to show it. Will it be stable or not? 1 second. I will, okay, 1 minute. I will try to assemble the system. And we will see, stable or not. 10 minutes. I will use this well. It's better amplified. This will be another coil, and this will be the coupling feedback coil, small one. I hope I will be able to assemble something. Space. I need more space. Block. To prevent electric shock. Prevent electric shock. Disconnect all power in the city. This. Move wires for the ductwork. Move wires for the ductwork. This is ground. Ground connected, this connected. Move wires. Okay, this is fine. Next object. Capacitor. This is fine. More object. Okay, maybe. Couple more objects. System may be stable, but system also may be unstable. I need this thing. It will act as a limiter. It's a gas discharge lamp. Will work as a voltage limiter. And so last nice object. Voltage can go up quite significantly. That's 4. I will write one. Fix it. This 4. This one. 1 second. Small check. This is okay. I need what I need. Okay, this will oscillate. This way should be fine. Last round. no disconnected generators do not work. Strange. Why? Okay. Why? Where's mine? Suppose. Let's see. This is fine. No. This is fun. What it was. I will fix the one here, of course. This appears to be okay. This one is nice. What kind of schematic do I have here? Right. Change a bit. To the ground. Yeah, I have coil. This is fine. Through the choke was 250 volts. Variable condenser coil. I have some losses resistance. This is to the ground. They are coupled with metal inductance. so I can control the feedback. And I have attached my pulse generator. Now you see reaction. Here I have splitting capacitor. Generator is here, and here I have resistance. Not important. Idea. What we have? What do we see? We see a reaction, response of my network to the pulse of 1 microsecond. You want, I can bit unfun. But here I will have a 50 volts. Okay, it's 1 microsecond pulse. After each pulse, it's like ting, ting. My system oscillates. What will be effect of the negative feedback? Can you predict? Coils are visible. Yeah. This is anode coil and this is feedback coil. Take a look. I'm increasing mutual coupling, meaning that I'm increasing a negative feedback. Hey. You see what's happened? Do you see it? The closer a coil, the stronger is a feedback. The stronger negative feedback, system don't will to oscillate. I'm changing capacity. See, it changes on frequency. Oh. Negative feedback makes system more stable as predicted. It's like choking it. Negative feedback increase linearity and key moment. Negative feedback increases stability. This system don't willing to oscillate. Oscillates. Near not oscillates. So negative feedback increases stability. In a different time scale. See? Stability. Coils are closer, negative feedback stronger, system more stable. And what about positive feedback? case of positive feedback, I should take minus coupling. My root will be minus alpha minus ms omega 0 squared divided by 2 plus minus dot square root of omega 0 squared minus alpha, minus ms omega 0 squared divided by 2, and this should be taken squared. I need to look on this term. While alpha minus ms omega 0 squared divided by half is less than 0, this term will be stable. Or f should be less than n ms. At the moment this one becomes positive, system will not be stable. Block, block, block. I'm changing polarity of the coil. I'm changing the polarity. Okay, let's take a look. Coils are visible. Yeah. Now feedback is positive. Or not? Sorry. This way will be positive. Look at. I'm increasing coupling. Coupling. I'm increasing. I'm increasing coupling and you see what happens? And becomes fully. You see the action? Less pulse. You see this long tailing? Small positive coupling. System seems still stable. I'm coming closer. Stable, stable, still stable. A bit more closer. See how long it takes to go down. And here is the point of instability. Here it is. System no longer stable. What happens? it oscillates freely. It became a generator. It can become a generator. Without limiter, 200 volts amplitude. Actually, if I disconnect this wire, volts. Without this limiter, I put a limiter. Voltage can reach 300 more volts. I don't want to risk. So with the what can we tell? But with positive feedback, system maintains stability until, see, still stable. Oscillates but returns to the stable. Hop, no longer stable. System, in my case, it's a generator. Stable, on a brink of instability. No, system is uncontrolled. It's become an auto generator. In real system may collapse. Common errors. Bridge would collapse. Inadequate driver, to the left, to the right, for left, for right, and oh yeah, we need an insurance. Unstable often means broken. Here, with the help of limiter, I keep my generator under control, but stable. Unstable become an auto. This one certain. Nicely generates because anode is selected. It generates on one frequency. Output system maybe. This coil is non-periodic, that's why one frequency. Funny toy. And I have harmonic signal generator. What's conclusion? Number one, system with return has a characteristic defined by both direct and feedback circuit characteristic. And second, system with return stable until all real parts on which polynomial roots are negative. If we have a positive part, system may become unstable. Now you see, it's not a stable system but a generator. In theory, if I, without limiter, it reached more than 300 volts, I don't know, do this with building like Tesla did, the building will collapse. At last you will be expelled from the laboratory. It what happened with Tesla. Okay, funny generator. Maybe some questions? It's too complex. Yeah. Okay, this means that I can